All right, aviators, hello, skygazers, hello, airplane lovers, and yeah, I said skygazers already. Whatever. Welcome to our first legit Project Aviate up and away lesson, brought to you by Project Aviate. I said Project Aviate twice. We're so excited. Thank you all so much for showing up here. We really, really appreciate it, and we hope you guys are doing absolutely amazing. And we hope we can make that day a little bit better for you, because now we're going to do probably the craziest thing that airplane lovers ever talk about, which is the physics of flight, which is crazy because you'll see why. We got some few action items to take care of really quick before we actually get into the stream. So just as a recap of last week, we talked about how this program's going to work. 15 weeks. We have our schedule and links to like our streams and our slides for every lesson. In fact, I'm just going to go ahead and show you that right now, just so you get an idea of what it looks like. So, am I looking at the right place? Yeah, I think so. So this is the spreadsheet that hopefully you guys all know of. So hopefully you guys have seen this spreadsheet before. This is our complete schedule with topics and notes for every lesson, as well as links to our YouTube live streams, such as the one today, and our slides here as well. And it also has the necessary resources that you'll need, which are in the green box. So you can find this spreadsheet in the YouTube description. You can find this in our emails, but this is our central resource hub, just so you know where everything is. All right, so now that we've taken care of that, anything else we need to go over before we jump right into this exciting lesson? You guys have anything to say?
I think we're good. Let's head in.
All right, so as you can see, we got a plane in front of us, but for now, we're gonna say goodbye to the plane. Say goodbye to this plane. We're not gonna see it anymore right now. And I say that because we don't know. We're now going to take the perspective of the scientists in the 19th century that didn't have planes to look at, that didn't know exactly how to make them yet. All they ever saw was birds, right? Like, when they asked, how do we get in the air, the only guiding thing they had were birds. And so that sort of brings up today's guiding question. This is our thumbnail, as you probably know. And that brings up today's guiding question. As you notice, it's not exactly a question. It's just, I want to get in the air. And that's because we're really serious. We're dead serious about getting in the air. And we want to do it. We just don't know how, right? And as we know, birds fly. And this is about the only inspiration we have for us to get in the air. So what do we do? What do you do with just a bird? How do you analyze a bird to figure out how you can make man, any human, fly in the air? Let's go ahead and start exploring that. So, what do we know about a bird so far? Let's make this a little bit bigger. What do we know about a bird? Now, I'm gonna have a pretty lame drawing here. So, here's a bird, right? Here's a pretty awesome bird. Oh yeah. And it's got like feathers, just like that. I think I did say I was gonna draw a better bird before, but that's okay. This is the best bird we have for right now. A bird has two major parts. We have the body of the bird itself, and then the two flat things on the side. You know they're called wings. You know that that's what a bird has that makes it fly. But for now, let's just say we don't know that. Like, we're just experimenting, trying to figure it out. So, oh wait, Roger, wearing headphones?
No, that was me, sorry.
Okay.
I actually blasted my ears.
Okay, yeah. All right, we're good. So yeah, we know these two parts of a bird. Now let's go ahead and let's imagine we were to dissect it a little bit. So here's the bird's. There's a bird's body, and then there's the wings, right? If you were to just take a lump of clay, for instance, and rolled it into the shape of a bird's body, and then you just threw it, if you just take literally anything, like if I just took this water ball right now and I just chucked it, it's not gonna fly, right? Like, you're just gonna break something. So we know right away that it's not the bird's body that's enabling it to fly. No, it is not the bird's body that's enabling it to fly. So what is? It has to be whatever the flat stuff it has on the side are. It has to be whatever this is. And as you know, it's the wings. But we're going to take a look at that right now. So, what does a bird's wing look like from the side, right? It's like, it's pretty flat. It's kind of curvy, but our best guess with 19th century observation skills is that it's kind of flat. It just looks like that. It's a flat thing. Sorry for the delay on the drawing. I'm not sure why that's happening. But this is basically all we've got right now. And we know that it's a thing that's moving in the air. So there's like air particles going all over the place. You might remember from elementary school, the 3 states of matter. The 3 states of matter are solids, we have liquids, of course, and then you have gases, which are just, particles flying around all over the place. And you probably remember this from elementary school that air is a gas, and air is made up of tiny particles that are going all over the place, And it's the same thing that's sort of happening right here with our flat object that's in the air. This flat object being the bird's wing, I guess, right? We just have air particles, just going all over the place, hitting the bird's wing, and then traveling wherever, right? So we can say, for a conservative estimate-ish, that, the air particles are like hitting the wing at every point on it, like equal amount. They're just hitting on the wing. And to understand that, this is what we call a force. This is what we call a force. And for those of you in high school, you probably know from conceptual physics what a force is already. But just as a primer, if you literally push anything, if you just push something and it moves, it's because you applied a force on the thing and it's now moving. That's all it is. That's all a force is, and that's all you have to know for right now. So now we have our flat object suspended in the air, and air is flying around all over the place and hitting it on all these points on it, all over it. Now we're going to take the assumption that we're moving forward. Obviously, a bird doesn't just flap and stand still, right? It's going forward. It's going places. Birds fly to go places. So similarly, our little flat object here is going to go places. It's going to go forward. For now, I'll just use the white arrow as the direction that it's going. If you've ever sat in your car and stuck your hand out the window, you probably know what happens. Well, you probably know what you feel on your hand when you stick your hand out the window as the car is moving. You feel all that air just hitting against your hand like this, right? So, and in that, it feels like the air is coming from in front and then just hitting your hand and then going behind you. So that's sort of what's happening here. As our flat object is moving through the air, all of it's just going behind us like this. It's just all going behind us, right? We can say that this is happening for all the air particles that are around our wing here. But what happens to the air that's aiming straight at the wing? What happens here? Because this, if you look at this yellow particle, which you'll see in a second, it's going to hit it, right? What happens? It doesn't just go right through it, right? Objects don't go through each other. I can't send my hand through this water bottle. So let's go ahead and blow up this wing. And by blow up, I mean enlarge. Have you ever seen in a textbook where it's they circle the image and then they expand it like this? So that's what we're going to do. Real fast. Just really blow it up here. Now let's take a particle of air and then just send it here, right? Now you can probably predict what's gonna happen. If you've ever seen, let's see, if you've ever seen like I was gonna talk about the assist later, but I guess we could bring it up right now. Is our slide there for it? Oh, we don't have our assist there. Okay, that's okay.
Yeah, I don't think we have a slide for it.
Oh, geez. Okay. You can probably guess what's gonna happen. As soon as it goes and hits this thing, it'll get like, it'll just go wherever, right? It'll just get shot up like this. Maybe an air particle comes here and it just gets shot that way. Maybe an air particle comes right here and then just gets shot that way, right? So it's what you guessed. Now you have all this air that's hitting against the front of our wing. And what happens is if we go back to our normal view, if we go back to the normal view here, if we go back to the normal view here, we have air that just gets sent up like this, just sent up. And the air coming from behind it also gets sent up with it. And it's like a ripple effect. It just keeps sending the air behind it even further up. Now, to understand the rest of this, we're not going to use any fancy scientific names. I'm not going to mention all the fancy physics principles yet. But instead, I want you to think of the concept of a bully. If you've ever been bullied in school, I hope you've not, but I think elementary schoolers or middle schoolers will often, I don't know, I feel like that's where the bullying happens mostly. Let's say you get shoved, right? You ever been shoved before? Well, think of that as happening right here. If we have air that's just flowing, the blue air that's just flowing normally on its own, and then we have our yellow particles go and hit it, it's kind of like a bully in that it's going to just send it away. You know, an air particle comes up here, no, get out of here. An air particle comes up here, no, get out of here. And this just keeps happening as all these yellow particles that got, you know, sent up by our green wing just get deflected back down, just like this. They just get deflected back down, and as a result, you get this kind of path to happen. The air starts doing this. It starts curving up and then comes straight back down because it's being forced back down. It starts from low, goes high, and then comes down. Kind of like that. And the first thing we're going to do is go ahead and get 2 sheets of paper. Just any 8.5 by 11 or even binder paper. Just 2 sheets of paper. We're going to be building a paper airplane with one of them, and we're going to be using the other one just as a normal sheet of paper. We're not actually going to fold it or anything. Oh, you got your paper there, right?
Yep.
One last thing before we go into building those things, and hopefully you have your paper on ready-ish. Now we talked about the air that's getting hit on the top here. We talked about all this air that's going on the top, but what about the air that goes on the bottom, right? What happens to that air? Well, since this is kind of flat, the air doesn't really change much. It's just going on its way. It's pretty flat here, right? Now, here's the final piece of the puzzle. This is the final piece of the puzzle. Remember how I talked about how in the beginning, all our air particles are just hitting the wing? When we weren't moving, all the air particles were just hitting the wing equally? Well, now, the same thing is true here. The same thing is true here. All these air particles on the bottom are kind of hitting it equally because they're just going, right? They're just passing by. So not much is happening here, but look here. Look up here at all the yellow lines. What do you notice? Well, there's actually an absence of air here because a lot of it got sent up by the wing itself. A lot of it got shot up like that. So what's happening here? there's essentially much less air here, and therefore much less air pressing on it. Like there's hardly any. That's why I'm drawing it with smaller arrows, just to indicate there's less air pushing on the top of our wing here, just like that. And this is where we've arrived at the final piece of the puzzle. And here's another analogy for you. If you've ever arm wrestled with someone, why don't we take a look at an arm wrestling match, just so you remember what arm wrestling looks like. I don't know. You know how in arm wrestling you got two hands, and then you're fighting over who's gonna win, right? Well, why don't I give you a pretty lame drawing of arm wrestling? Oh yeah. Did I even draw a hand properly? Okay. We're gonna assume that this is a pretty amazing hand. All right. Let's say this guy's pushing this way, and then these two are pushing against each other, right? They're trying to win, right? But then suddenly one of you decides to stop pushing. Maybe you just give up, right? Maybe your muscles feel sore. I don't know. You just give up. Well, you can obviously guess what's going to happen. You get toppled over. You just get toppled over, right? Well, similarly, that's actually what's happening here. That's actually what's happening on our wing. In fact, the air around our wing is playing a giant wrestling match. It's playing a giant wrestling match.
Wrestling match.
Exactly.
Arm wrestling match.
No, wait, let me pick a
wrestling.
different color just to... Oh, I hate how that takes a while to show up. Yeah. Lighter color. Good. There's an arm wrestling match between the... Sorry. What is wrong with this thing? There's an arm wrestling match going on between the air on the bottom and the air on the top, and suddenly the air on the top isn't pushing as hard. The air on the top isn't pushing as hard anymore. So what's going to happen? The air on the bottom wins the wrestling match. The air on the bottom is now pushing harder. It's now pushing harder, and therefore it sends our wing up. And that, my friends, oh god, I dropped my thing. That is how we start to get an idea of what is lift. How do we get a flat thing and just send it in the air? Now, you're probably looking at this and like, oh my god, it's drawings, it's lines. I have no idea what this is. And you know what? That's okay. That's what we're going to show you right now. So Yuvraj, you got two pieces of paper in front of you?
Absolutely.
All right. So we're going to go ahead and take one piece of paper right now. And Yuvraj, we're going to do the one where you blow on the top of it.
Okay.
You know that one, right? Yeah.
I don't, but I think I know what you're talking about.
No, it's like
So,
you... hold on. I should probably... How do
so
I
you just
not
fold
have...
it in a bunch of times, right?
No, you don't. No, you don't fold it. Just hold the paper up and then blow on the edge of it.
Oh,
So,
over here? Like...
yeah, but hold it from the edge that your mouth is at.
I'm sorry, I'm not
Sorry.
sure. Like
oh.
this or this way?
Hmm?
This way or this
Now
way?
move your hand. No, go back the other way.
I should have had like a printer
Now
paper ready.
put your
Count to
hands
30
closer
seconds.
to the
I will
corners.
be right back.
Put your hands closer to the
Okay.
corners.
Oh,
Yeah,
here,
yeah.
okay.
Okay, now rotate your paper like 90 degrees, like other way, like instead of
Oh,
yeah.
like this.
No, like now, yeah, like that.
Oh,
Yeah, there you go.
oh, okay. You want me to blow on it like this? Thank you.
Sorry, hold on. I just got back. Give me 1 second. So what we're gonna do is, yeah, just blow on it like that.
Oh, who's gonna win that fight or not fight match? Dang it, you had to enlarge him.
If you blow on the top of the paper, what do you notice happen? Right? If we blow on the top of the paper like this, the first thing
Wow.
you'll notice is the back of the paper starts fluttering upward like this. right? This is the cause of all the air that's like curving over our wing here. It's causing it to just lift up. So this is kind of what lift is. It's this sensation of air going over our surface. And depending on where you blow it might be a little bit harder to get it, but try to blow above the piece of paper like this. And that's basically what lift is. I can see Yuvraj is getting very much into it. Okay, yeah. Very good job, Yuvraj. We'll have a
Thank
round
you.
of applause for Yuvraj right here, even though
I'm
we
about
can't
to
hear you guys
pass out
clapping. I hope
now.
you guys are I hope you guys are applauding from your houses or wherever you guys are. Let's just go ahead and so yeah, now you get the idea of what is sort of causing lift, but it's still like a mumbo jumbo
And
of air.
Just
We need
just to be clear,
Yeah?
just real quick, I understand that it will be difficult to tell on camera, but I was blowing over the paper, not underneath it, pushing it up. I was definitely pushing the air over the top of it.
Yeah. Make sure you're doing that. All right. So basically what we just demonstrated is that we can have air curve over it, right? And somehow this
Yep.
causes lift, right?
Mhm.
And what's causing sorry, pick a different color. Just like the air is curving around like this, right? And what's causing all this lift? It's an air particle being hit here, getting sent up, and then it's being deflected back downward, just like that, right? So we get these general paths. Now, as you know, most airplane wings aren't flat, probably, but actually, they were once flat. Why don't we show you what we have next? You probably know who the Wright brothers are. First people-powered flight, right? The first thing you might notice about their Wright Flyer is that the wing is pretty flat. It's kind of curvy, but it's pretty flat. And this is how most wings were when airplanes were first starting to be built. It was pretty flat. And we also have not just the Wright brothers, but Alberto Santos-Dumont. This is a guy from Brazil. He's basically the Wright brothers from Brazil.
He's the right brother.
He's the one man Wright brother of Brazil who helped make the powered airplane. And his airplane looked like this boxy, weird thing. And it still works though, even though the fact that the wing is flat, you know? Now would be a good time to build our paper airplane, so you, Raj, why don't
Let's
go
go
ahead.
for it.
Yeah, go ahead and build the paper airplane now.
Okay. So in the interest of time, I'm not going to make the best paper plane I know, but I'm going to make it good enough and you're going to be able to follow along. So first of all, fold it in half down the long side of the paper so that you can accurately curve it in when you need to. So I'll wait a second or two. Let me know when you want me to move on to the next step.
You just go right through it. They'll be able to
sure.
replay it.
True. So we're gonna fold the edges in first. I'm gonna kind of do some quick and dirty origami. Second side, and then we can fold this corner inwards on top here. Again, the line down the center will help you align everything properly. I like to spend an extra second doing that. The other side. Go over the creases with your hands. Really push them in, it'll help. And then make sure you have the open side on the top. Then fold it in on itself. Then feel free to slow down the video if I'm going too fast later on. And then you take these leading edges over here, and we're gonna fold these in this way, and that'll be our wings. Be careful towards the tip. the nose of the airplane. Press the creases down. And then you slowly flip it over. Well, not slowly, but fold in the other edge. Now, if you carefully open it up, you'll see 3 edges. Lay it flat. Push the creases down. You have a paper plane.
Nice. Also, can you go ahead and find the center of it? So use a
Center, which
yeah.
way?
So
Over
long.
here?
Yeah. So like use a
Okay.
pen and then like roll it on.
I have
roll it on it.
If you give me a second, I have a ruler.
No, you don't need to measure it. You can just use a pen
Oh,
and then check
right.
when it tilts.
Mm-hmm.
Yeah.
So I'm just gonna mark the center.
Not like that.
Oh,
Like lay
balance
it on. Yeah, balance it on the pen. I meant. Sorry. Put it on the table though, so you can do it. You can just drag the plane.
It's like right about here.
Oh, I knocked it. I found it.
Yuvraj, you can keep the pen on the table, and then just move the plane along it until it tilts to the other side.
Oh, almost there.
Yeah,
Right
so
here.
the moment you start seeing the tilt, that's mark where your pen and the paper airplane meet. So mark that spot.
Mm-hmm. Right there.
Yeah. And it doesn't have to be terribly exact, just mark about where it is. Hurry.
Got it?
Okay, good. So now you have a paper airplane basically, and when you launch it, you want to make sure you're holding it slightly in front of that marker. This will help it, get in the air better and fly longer distance. But
So this is the
yeah.
center of gravity for the plane.
Yeah.
Hold it a little bit ahead so that there's a little bit of a nose up angle when you launch it.
And then you can just launch it. Please don't poke anybody in the eye. But basically, the thing we want to show you here is that an airplane can fly with a flat wing. Paper is flat, and paper has the paper airplane has a flat wing basically. And so, what if we want to make this effect even more though, right? Like, what if we want to take hundreds of people in the air, right? How do we do that, right? Like this force that you see here is only sustaining our paper airplane to fly across the room, right? But I want to fly across the Atlantic. I want to fly across the Pacific. How do we do that? How do we increase the amount of lift we're generating? That's the big question. Well, it turns out if we go back to the basics, if we go back to what's actually causing our wing to gain lift in the first place, it's all this deflected air, right? It's all this deflected air here. This is what's causing that whole sensation of, oh, there's less air here, and arm wrestle battle, and the bottom air wins and pushes it up, right? Let's say we want to make this effect more extreme. Why don't we take why don't we punch that air, right? I want to punch it even higher above our wing. Let's take the original wing we had, and I want to punch it, like make it curved, like this. So instead of going flat like this, like our original plan, let's make it curved so that we can punch the air more, right? So that when the air comes here, we can punch it even higher. Even higher. And then why don't we finish it off like that, right? And then like make it smooth in the back, right? But basically the idea here is we want to punch the air a little bit more. And as a result, we're sending our deflected air even higher. And therefore, we're creating a larger region where there's less air pushing down on the bottom. And this way we can increase the amount of lift we're getting. And that is essentially what we're looking at with our modern designs of airplanes. So why don't I actually show you that right now? If we go ahead and zoom in on it. Let's get rid of that. Let's get rid of that. What do you notice? It's the
Plane
exact,
time.
it's that exact design. We've got a curve, and then it's curving down like this. The air is coming from in front and getting punched up like this. Getting punched up like this. And slowly curves back down, and we have our lift. So this is our fundamental shape of the airfoil. And now you know how lift works. And we will never, ever go over the complicatedness of this physics in the rest of the series anymore, because I think one lesson is quite good enough for it. But let me bring back the tablet. Yeah. All right. So now that we have that, now we just need a way to steer in the air, I guess. Because what else have you seen a bird do, right? What else have you seen a bird do? It's not just going straight, right? It's not just floating. It's not just gliding. It's actually turning. It's actually climbing. It's actually going down. You know, how does it do all that? How does it do all that? Well, it turns out that there's an easier way to do this than, you know, just building more wings. So we have our plane now, right? We have like a body and then plane, right? Now we have a plane. And the side of the wing looks like that. Right? But I wanna turn, right? Let's say I want to turn like this. You notice how birds turn in the air by literally rotating their body like this, and then they turn? And it turns out that was a horrible pun. It turns out that this is a good way to turn our airplane. And how do we do that? The idea is we need to somehow tilt our plane, so that it's now facing like this, right? So that's now facing like this. And basically that just means sending one of the wings down. We're sending like the left wing down and the right wing up, right? We can go ahead and make this a little bit easier on ourselves. What should we do to cause one half of our airplane to go down and the other half of our airplane to go up? What should we do, right? So let's take the left wing as an example. Let's take the left wing as an example here. Well, we know air is coming. We know air is coming, right? We know air is coming like this. If we want to send this wing down, why don't we go ahead and so this is something else now. If you've ever like pushed against a wall, you feel the reaction of you going backwards, right? If you push against something really hard, you feel the reaction, right? Similarly, why don't we go ahead and push the air? Why don't we go ahead and push the air up like this, right? Why don't we add a little piece here that causes the air to get pushed up? And as a result, the reaction is that now we're forcing this wing to go down. The reaction is we're forcing this wing to go down. So now we've figured out how to make our left wing go down. And you can actually, oh wait, let me explain the right one real fast. And similarly, it's the opposite for the right wing. We want the right wing to go up. So what do? Take the wing, and then add a little thing going down like that, so that now we're deflecting air down, just like that, and sending the right wing up. And now we're able to roll our airplane to the left. And you can actually go ahead and do this. Yuvraj, let's see your paper airplane again.
I don't think you're. Oh, there I am.
Yeah, go ahead and make the left side, bend up the left side, make an aileron out of the left side.
Yeah, ailerons on the.
Yeah, just like
so
that.
So bend that side up, and then bend this side the other direction.
Yeah.
Now you have ailerons.
Yeah. These little flap things that we're adding to the wing now are called ailerons. And if you go ahead and throw this, you'll notice if you throw it right, make sure you're holding from a little bit in front of the marker. If you throw it, you'll see the airplane start to turn to the left, ideally. Once again, don't poke anybody. And yep, thank you. And finally, as you probably know, if we want to go ahead and roll to the right, if we want to roll to the right, it's the exact opposite. We're just sending the left wing up and the right wing down. It's the same concept. So now we know how to turn in the air. Finally, how do we go up and down? Well, now let's take a look at our plane from the side. Let's take a look at our plane from the side again. Oh, wow, I can't draw. Let's take a look at our plane
Are we
from the
going
side.
up first or are we going down first?
We're gonna
'Cause
go
I can make
up.
elevators too.
Yeah, so we want to go up, right? How should we do that? Well, it turns out there's two things we can do, right? Let's just do the way that is normally done with airplanes. And if you were to send the back of the plane down, you can send the front of the plane up. Because
It helps real quick. I'm just gonna butt in. It helps to think of that the mark we made on the plane, the black mark that I made where the weight was rested. It helps to think of that point as a pivot, so that when you push, so this black mark. So if you push down on the back, the front goes up, like
Yep.
that. And then if you push the back end up, the front goes down.
Yep.
So it helps to think of it like a seesaw.
Yeah, that's actually a better way to put it. Yeah.
Hmm
Kind of like a seesaw. So it's actually very much the same idea. All we need to do is have like a mini wing in the back and do the same thing. If we want to send it down, if we want to send the backside down, well, that's just like we were trying to send our left wing. That's just how we were trying to send our left wing down. And so the way we can do that is by adding a little piece right here that deflects. Sorry, let's pick a different color. That deflects our air upward, just like that. And we send the back going down, front going up, and now we're able to lift off, just like that. And once again, it's the opposite for going down. And there you have it. Those are actually, Yuvraj, why don't you show how to set it up on the...
So just, it's just a
Sorry,
green screen.
There we go.
There I am. Okay. So again, I marked, this is a different plane I made. It's better. But yeah, this is the center, the pivot point that I showed you. So now if you want to point the nose up, what you can do is instead of pushing these into different directions, you push them up in the same direction. So both of them up instead of one down and one up. When you do this, the air is deflected up and it pushes the back down, pushing the front end up. And then if you want to push the nose down, you just simply flip these around. So, push that one down, push this one down. Now the air is deflected down in the back, so it pushes the back end up like this, which pushes the nose down.
Yep. Also,
Bam.
make sure not to fold it like too much.
Not this much.
Yeah.
I'm making it really extreme just to show you the principles. But
Yeah.
if you gently even touch it and just push it downwards, that's all you need.
Yeah.
And that's airplane physics. Easy.
Well, congratulations. You have now made it through basically everything that every single flying machine that you see today rides on.
A lot of helicopters.
Even helicopters to a degree.
To a degree, yeah.
These very fundamental concepts. And we will lecture no more. And now we want to actually see all this in action, right? Like you've built your paper airplane, you probably see it, you know, plane going up, plane going down, plane roll left, roll right, stuff like that. And that's basically here's basically what they commonly teach you in flight school. It's that you have like 4 forces just like this. You have your lift, so primarily it's lift that's helping you go in the air, and it lets you counteract. It basically lets you overcome the fact that airplanes are heavy, right? You probably know what gravity is. You know it's pulling you down to the earth, and it's the reason you can't just, I don't know. Who's the superhero that does this? That just points
Superman?
their fist? Yeah, Superman, whatever. It's the reason you can't be Superman. I'm sorry to crush your dreams, but that's basically the reason we have to do all this complicated airfoil wing thing. Yeah, I should just say wing. Yeah, and thrust
Oh,
is
uh,
just yeah.
I just want to specify that Nikhil mentioned the air going over and under the wings. And to push, the reason there's so much air passing over the wings very quickly is because of the engines you see on the plane, which push the plane forward through the air. So
Yeah.
just want to clear that up. If you don't have air going over the wings fast enough, or if you don't have enough air going over the wings even, you'll run out of lift and you'll stall and the plane will fall out of the sky. So
You know, an easy way to
good-
test
good
that.
to keep moving.
Yeah, an easy way to
Watch.
test that is to take your paper plane and drop it. That's all you have to do, basically. And
Look, bam. If I push this through the sky, though, if I push it, it'll keep flying.
yeah, that's the reason you throw it. It's to give it that forward speed, and that's basically the responsibility of the where's the thing? That's the responsibility of this thing that you see called thrust. You see the circles on the wing there? Those are the engines that are doing the throwing. They're throwing the plane forward, basically, and that allows us to get into the air.
That's
Um,
right.
We won't worry about drag for right now. Just understand that we're going forward, we're getting lift, and we're able to roll left and right and go up and down. Just like, oh, you can't see me for a second, sorry. Just understand that we're able to go forward, we're able to roll left and right, and we're able to pitch up and down just like this. And now we're able to get into the air, and you can actually see those axes of you can actually see that.
Oh, we
happening.
forgot to demonstrate yaw if you want to.
We'll deal with that later. We're not gonna do that right now.
Sure.
Yeah.
No problem.
So, that's basically it for the fundamental flight physics. If you have any questions, please go ahead and drop them in the chat. We are monitoring the chat. And if you have any other questions, like after this stream, you can go ahead and email us,
Nikhil.
flyprojectaviate@gmail.com. Yeah.
Why don't we give them some explain time while we answer questions?
Yeah. Yeah, we can go ahead and do that. Do we want to talk
Yeah,
about
just
mobile
fly
flight
around.
sims right now, or
Oh no, they want to see you fly as well.
do they want to see me fly right now?
I think they do. People were asking me if we were gonna get explain time today. Let's give them some.
Okay. Let's just. Oh,
So I can answer one question. This question was not in the chat, but it was from our email, and it is regarding chill streams. So chill streams are not planned in advance. They are basically pop-up streams that we do. But we will be sure to email everyone a few days in advance for you guys to know that we will have a chill stream that week. We don't have like a specific day that we do them, and we don't have like a time that we do them. So it's like a pop-up stream. And we try to email like as soon as possible that we know we have one planned. But on the spreadsheet, it has all of our planned lessons. I can drop the link to the spreadsheet in the chat, but that link to the Google spreadsheet has all of our planned lessons that you can expect us to follow.
Yeah. Oh, and real fast, this is all these green arrows that you see. This is lift. This is lift happening on every point on the wing. The lift happens all over the wing because the whole wing is shaped the same. So we get lift like everywhere. And as you can see with the engine, our thrust is happening. It's throwing the plane forward. That's what these yellow arrows signify. It's throwing the airplane forward, basically. And that's it. That's how we're able to get in the air. Just like that.
I have a request, Nikhil.
Yeah?
Let's kill the engine and watch the plane slowly slow down, and let's watch the air molecules
Oh, please
slowly
no.
stop going over the wings, and then it'll fall and
no.
we recover.
Please
Let's
no.
give it a shot. Pull the mixture.
Let's
Do it, Nikhil.
It is 5:15.
Oh,
Or
I see. We're out of
5:16.
time.
Yeah, we are out of time.
We're out of
We
time.
will go. The rest of our streams from now on will be involving X-Plane Mobile. So make sure to go ahead and get that in the App Store or Android free. You'll get to see this as well, and we'll show you how to move around in X-Plane Mobile in our next stream, which is going to be 2 weeks from now, as most schools, I believe, have a holiday next Friday. So we'll be seeing
Yep.
you guys in 2 weeks. If you have any questions, once again, go ahead and either drop them
There's
in the chat
one
or send us
question.
an email. Yeah?
Liz asks, how do you find the runway when you land?
Oh.
So you could look around to see if you can find an airport, but in future streams, if I can pull up that schedule, there will be one stream where we discuss charts and maps, like aviation maps. So those are maps that pilots use. It's similar to like your Apple Maps or an app that you use on your phone to find your way around town, but it's
Yeah.
for aviation and it's for pilots. It's very similar. It has airports and it has basically where they're located, instructions, and then basically on the airplane you have a GPS and you can enter in that airport and it'll guide you to the airport.
Yep. And we'll be going over that in a future stream. All right.
Probably May 14th, cross country.
Yeah. Okay. Any last words? I don't think so. Well,
Any last
any
words?
last words? Yeah. Well, anyway, thank you guys so much for joining us today on Project AVIATE Up and Away. Don't forget to touch down on the like and subscribe buttons. Help support our channel. We're continuously growing with thanks to the help of students just like you. And happy flying, and enjoy the picture of the whale. We'll see you guys 2 weeks. Enjoy your weekend. Enjoy flying. And don't get nightmares about air flowing over wings. Or try not to.